So, coalescing media. So, coalescing media actually this promotes water droplet to collide each other and creates larger surface area. So, coalescing area may have like corrugated system we have discussed already, right, or you have hay section, or one term they are using Excelsior. Okay, or hay section they say. So, if you have small pores, when fluid is passing through small pores, they will be colliding more and it will be creating more bigger particle. So, Excelsior lowers treating temperature, lowers treating temperature. However, these clogs with time, so difficult to remove. Okay, so because very small pores are there, so it will be clogging quickly. So, and again difficult to remove, they are saying. So, that is why people are avoiding to use this one these days. Okay, and these are actually tightly packed. Tightly packed creates obstruction of flow of small droplets and promotes collision. Okay. So, small hay section layer by layer you create, and you are creating actually obstruction. So, because of obstruction creation, particle will be colliding quickly, but it will be clogging also quickly. So, positive negative both sides are there for Excelsior. Okay. We will discuss gunpowder later. First we will discuss horizontal separator. Horizontal heater treater. Okay. The same way you have horizontal separator system as vertical you have seen. Okay. You have inlet flow, inlet diverter, right. Now, you will have 3 sections basically. One section will be like heater treater system will be going there. Can I draw like this? Okay. I am drawing this one like this is coupling or flange actually we say. Okay, when a pipe end will be there, so you will have certain flange or nut bolt system. Okay, in mechanical system we say flange, so nut bolt thing will be there. So, we made a little bit larger area, and there you can put nut and bolt and you can fix with other pipe. Okay, so this is a cut view. Okay, like it will be like this. One flange will be here, another flange will be here. Okay, let us say one pipe is here, another pipe is here. So, there will be nut bolt. Okay, lots of holes will be there, and then you put bolt in nut and thread, you tight it properly. Okay, and in between when you are putting nut and bolt and two flange are connected, in between you have to give proper sealing arrangement. So, rubber arrangement, elastomeric arrangement. So, sealing will be proper. Okay. So, again you will have spreader. Okay, and you will have spreader. Okay, and deflector, this is actually deflector plate. So, lots of fluid turbulence you are creating, and deflector. Okay, and drain valve will be here, and your oil will be collected here. Okay, this is surge, this is called surge section, surge. Okay, and this area lots of water is there. So, water you have to take out. Okay. So, free water you are taking, actually this is free water. So, it is not linked with emulsion at this moment. Next level we will go for emulsion thing. Here you have again this water will be sprayed here. Okay, whatever emulsion you are getting here. Okay, then you may have electrostatic precipitator separator here. Okay, and you can take oil from okay, you can take from oil from top, or some other mechanism you can make, you take oil out, because this area, this right side area, you are giving more time for settling. Okay, you may have your electrostatic system, or you give more time, so that settling will be especially this coalescing will be happening there. Okay, initially you are heating, then surge section is coming, so oil you are taking out, so that oil again you have to separate and you have to make water out. Okay, small amount of water you are getting and oil you can get out here, and this is actually emulsion coalescing section. Okay, so then it is having three section actually. This is front section, and this is surge section, surge, and last section is your coalescing media section. Okay, so this is having three distinct section, but in vertical separator you had actually four sections. Gas section was there separately. Okay, for low gas oil, this is most used for multilateral oil, sorry, multiple well bore, multi well case. Okay, many well bores are there, so in that case you can use. Okay, then but vertical separator, normally single well gas you can use vertical heater. Okay, for low gas oil ratio, blanket gas may be provided so that internal pressure you can maintain. Okay, if pressure is very low, so in that case you can use gas from other source and you can maintain the pressure. Okay, level safety low shutdown valve will be required, because level if not maintained in both cases, in horizontal or vertical. So let's say water level is gone very low and the pipe heater pipe is gone in gas area. So what will happen, the heat will not be carried out, so it will be heated too much. When heating rate is very high and you are not removing the heat, so that heat accumulation will be creating problem. It can create fire, because high temperature, it can reach to ignition temperature or burning temperature of fuel. Okay, oil or gas. So burning temperature means again chemical reaction will occur, so that can be disastrous. So you must have level controller. So you have to check how much level is there for oil or water. If you are not maintaining that one, then that can be a disaster. Okay. So temperature control must be there. So you have to check temperature, you have to maintain level, then you can use safely. Okay. So in surge section there must be level controller. Okay. So if you don't have level controller, then temperature can go up suddenly. Okay. Then you must have temperature sensor also. Okay. So front must be sized to handle settling of the free water, and you have to heat oil and water. Okay. Coalescing section must be sized to provide adequate retention time for coalescing and allow coalescing water droplet to settle down. Okay. So water droplet will be settling down, oil will be going up in coalescing section, the right side section. Okay. Most horizontal heater built today do not use fire tube. What they are doing, heat is added to emulsion in a heat exchanger before it is entering. So inside separator they are not giving fire. So outside giving heating up system, then you are putting emulsion mixture inside separator. Okay, just to make things safe. Okay. Before the emulsion enters the heated treater, hence the inlet section of the treater can be fairly short. Okay, because heater treater is not there inside that pipe, so inlet section can be shorter. Electrostatic heater treater. Okay, electrostatic treater means you are heating plus you are giving electric field. So that way you are reducing temperature, fuel requirement, and you are separating again. Okay. So it contains two or more electrodes. Okay. So you know electrode, if it is positive is negative, so negative ion will be coming towards positive electrode, right? And positive ions will go to negative electrode. Okay. So you know from basic chemistry book. One is grounded to the vessel and other will be suspended in the liquid. Okay, and volt applied will be like 10,000 to 35,000 volt you are applying. Okay, so normally AC voltage you are applying, AC current, and power consumption will be 0.05 to 0.1 kVA per square feet area. So kVA, I think you know the unit, kilovolt ampere means kilowatt actually. So volt into ampere is kilo, 1000, right. Used for electric field in most effective and viscosity less than 50 cp. Cp, okay. Viscosity less than Cp, in this case electric field application is very good, very efficient, okay. And del Sg specific gravity difference 001, okay. So specific gravity, and electric conductivity of oil and water phase does not exceed conductivity, does not exceed should be less than 0.0, no, not 10 power minus 6 mho per centimeter. You know mho, OHM is resistance. So resistance means you are resisting something, and conductivity means you are pushing quickly, okay. So just opposite. So that's why they put the name mho, okay. Ohm means resistance, mho means conductivity, conductance, okay. So electric control transformer must be used to increase the voltage, because voltage is very high. You can see 10,000 to 35,000 voltage. Normal our electricity supply at homes will be 220 volt, and 440 volt will come to your nearby transformer. So there will be one step down transformer, okay. Step down transformer, okay. What does it do? You have 440 volt supply, like 3 wires will be there, right, and when 3 wires to your home, it will be coming as 220 volt, and your normally your electrical system at home, it will be 220 volt. If you go 440 volt, everything will get burned, okay. So for our day to day application, 220 volt we are using, right. And many our electronic systems, they do not use 220 volt also. In that case, we will have some rectifier and other mechanism, so that you are reducing voltage, okay. So how transformer works? Transformer will be like this, okay. It will have, better I will draw other way. This will be there will be laminated core. This is a laminated core, okay. So laminated core means lots of thin sheets will be there, okay. You are creating rectangular thin sheets, okay, with central hole, okay. So one sheet, two sheet, three sheets, many sheets you create, laminated core, iron core. Now you have that coil, okay. So this is primary side, this is secondary side. Secondary side will be like this, it is going, okay. This is secondary. So here number of turns in primary and secondary, this will be deciding how much voltage you are increasing or decreasing, okay. This is a primary side 440 volt, and secondary side you want to 220 volt. So how many terms will be there, turns should be there, you have to calculate, okay. So let us see simple calculation. So normally copper wires will be used. Why do you use copper wire in electrical system? Because conductivity is very high, conductivity very high. We can use gold also, but gold is expensive, so we have to optimize somewhere. So copper wire we use it for normal common applications. Aluminum wire also can be used. Many places it is used actually for high tension lines, aluminum. So based on cost and conductivity, people will be using, okay. And this transformer mechanism works on Faraday's law. 200 years back he developed, okay. Electromagnetic principle will be used. So conductance of one, it will be inducing conductance of another circuit, okay. So left side or primary side, you have some electricity voltage, so that will be induced, that will induce voltage and current in secondary side, okay. and you have to insulate the conductors, and when you are insulating you have insulator oil. So, many time you use transformer oil, you say, okay, and sometimes insulation tape will be there, normal electric circuitry wherever will be there. So, you will be seeing the one rubber or plastic or some material will be there over the wire, so that electric leakage will not be there, things will be safe, okay. And sometimes wood or laminations also possible to cover things, okay. Now, voltage and current, voltage and turns relationship is like this: V1 by N1 equals V2 by N2. This is the formula. Voltage in primary divided by turns in primary, voltage in secondary, turns in secondary, okay. Now, if N2 greater than N1, N2 means this is N2, this is N1, this is V1, this is V2. So, if N2 is more, number of turns is more in secondary, that means you are stepping up, voltage will be increasing, okay. So, is it step up transformer, okay. If opposite, N1 less than N2, N2 less than N1, so it will be step down, okay. So, in your household, the current is coming nearby transformer, they are actually step down transformer they are using, okay. Now, if I give one problem, let us say the problem will be like this. Let us say N1 I am giving, N1 equals 600 tons and N2 is equals 20 tons, V1 equals 140 volt, what will be your V2? So, simple formula you can apply, right. So, K equals E1 V1 by N1 equals V2 by N2. So, this will be giving E, instead of E you can write V, V2 equals okay. So, V2 equals 140 into 20 divided 600 equals 4.6 volt, okay. So, initially I had 140 volt, it became 460 volt. So, step down happened, okay, because number of turns changed 600 to 20, one small thing, then I will close. Now, similar type of transformer, let us say I have N1 equals 1600, I equals 6 ampere, okay. N2 is given 1000, so what will be the I, okay. So, in that case again I1 N1 equals I2 N2, this formula you can use, and directly I2 you are getting I1 N1 divided by N2 equals 6 into 1600 1000 equals 9.6 ampere, okay. Thank you very much for this lecture. Tomorrow we will start new topic. Thank you very much.